Hey everybody, in this video lesson we're going to talk about the law of conservation of matter. And we're also going to get into some basic balancing of chemical equations. First, let's talk about the law of conservation of matter. In a chemical reaction, you have reactants and you have products. And those reactants are made of atoms and those products are made of atoms. And what's different between the reactants and the products is that the bonds are different. In the reactants, the bonds might connect atoms in one way, but you break those bonds and recreate new bonds to form the products. But the atoms on both sides of the reaction arrow have to be the same, and not only the same, but in the same quantity. And so the law of conservation of matter says that matter, or atoms, can't be created or destroyed in a chemical reaction. If that's the case, when we write our chemical reactions to look like this, for example, H2 plus I2 gives me HI. If I draw out the picture of the reactants and the products, you can see that on the left here I have two hydrogen atoms bonded together and two iodine atoms bonded together. But on the product side, I only have one hydrogen bonded to one iodine. Well, as it sits, it looks like some atoms of hydrogen and iodine have been destroyed. And that can't be true because in the law of conservation of matter, atoms cannot be created or destroyed. And so I have to think about how I can balance the atoms on this reaction, basically come up with a way to get them to be the same on both sides. Now looking here, you can see that I have two atoms of hydrogen, that's the H2, and two atoms of iodine, that's the I2, but the one H and the one I from the HI. But basically I have more hydrogen on the left than I do on the right. Now if I want to take and double my hydrogen, I can't just double the hydrogen. I have to double the hydrogen and the iodine because hydrogen is tied to the iodine in this molecule. So I need double the hydrogen. Well, I need to double that entire molecule. And that's okay because, in fact, I need double the iodine as well. And when I double this molecule, when I created two molecules instead of just one, now I have two hydrogens on the left and two hydrogens on the right. I have two iodines on the left and two iodines on the right. So when I go back up to this reaction right here, I put numbers now. I count how many molecules I have, each one of these. Well, I have one hydrogen molecule, I have one iodine molecule, and I have two of these HI molecules. And now I have a balanced chemical reaction. It's balanced because I took multiples of my HI to make sure that I have the same amount of hydrogens and iodines on both sides of the reaction arrow. So the balanced chemical reaction is achieved by putting numbers out in front that represent multiples of that molecule. In summary, to balance a chemical reaction, you need to look at how many atoms of each element are on the left-hand side of the arrow and the right-hand side of the arrow, and then figure out if I can multiply any of the molecules on the left or any of the molecules on the right so that I have equal numbers, so they balance, because I have to conserve matter. I have to have the same numbers on both the left side of the arrow and the right side of the arrow. And in this example, I doubled my product, and as a result, I balanced the reaction with equal amounts of hydrogen and oxygen. If you take a close look at the bonds, you see that at first hydrogen was bonded to hydrogen and iodine was bonded to iodine. But in the product side, hydrogen was bonded to iodine. It's almost like I broke these bonds and then allowed the hydrogens and iodines to reconnect and form new molecules. And that's exactly what happened. Let's see if we can balance this next example. I have CH4 reacting to make C plus H2. Now if I draw, once again, my little cartoon drawings of each of the molecules and atoms underneath, over here, you can see that I have a carbon in the middle with four hydrogens connected to the central carbon. Now over here I have just an atom of carbon, and here I have once again H bonded to H. Now on the left side of the arrow I have one carbon, and on the right hand side of the arrow I have one carbon. And so those two atoms are in balance. But the hydrogen, you can see I have many more of those on the left than I do on the right. I have four here. Now I can only multiply this molecule so I can take multiples of it. And so let's do that. Right now I have two hydrogen atoms, but let's make four hydrogen atoms out of that. So I've doubled this molecule. I've taken two H2s. Now when I count my hydrogens, I have 1, 2, 3, 4, which matches the 4 hydrogens on the left. You see, I've got 1 carbon plus 4 hydrogens on both the left side and the right side. But the form in which those carbons and hydrogens make up is different. This has 1 carbon bonded to those 4 hydrogens, where this has just a carbon and 2 molecules of hydrogen bonded to hydrogen. And now I've got a balanced reaction. But my coefficients, which is what we call these numbers out in front of each of these elements, these numbers out in front are called coefficients. These coefficients are 1, 1, and 2. So once again, I had to change one of the numbers in order to balance the reaction. The pictures down below help illustrate what's happening up here. Since I have 2 of these, then this is a 2, but I only have 1 carbon and 1 of these CH4 molecules. Here's another example where I have Na plus Cl2 gives me NaCl. Now again, I'm going to draw my little cartoon drawings underneath each one. Now over here I have just an atom of Na, so I just have a circle with Na in it. Now here I have that Cl bonded to Cl, and over here I have Na bonded to Cl. Now I look closely at my sodiums, my Na, and I see that I have just one Na on both sides of the reaction arrow. And so the Nas are fine. Now let's take a look at the Cls. Now I have 1 Cl over here, but 2 on this side. Now I don't want to multiply this Cl bonded to Cl anymore, because that's just going to get me higher and higher and higher numbers. No, I have 1 Cl here and 2 here. Now I've got to double my chlorine, and the only way to double my chlorine is to also change the number of sodiums that I have. So over here, I've doubled my chlorine by doubling the NaCl. I can't just get more chlorine, I have to get more sodium and chlorine together. I have to double the whole molecule. Now when I do that, I now throw that sodium out of balance. I used to have 1 of each, but now I have 2 on the right side. So all I need to do is come back over here and go, oh, well, I need more sodium, and so let's do it. And I just multiply my sodium by 2 to rebalance that sodium. And when I do that, now I have 2, 1, and finally 2. I doubled my chlorine on the right because I had 2 chlorines on the left. But by doubling my chlorine, I also doubled my sodium. Now when I double my sodium, I have to go back to the left-hand side and double my sodium here. And now I have 2 atoms of sodium, 1 chlorine molecule, and then 2 of these NaCls. This is the first example in which I had to put 2 numbers in the balanced chemical reaction rather than just 1. And sometimes it's going to take 2 or maybe even all 3 numbers to change in order to get the correct balanced reaction. Now the cool thing about balanced reactions is that there is a correct answer, and you can figure it out, maybe by guess and check, but you would be able to figure it out. It is possible. You just have to have a little bit of determination, a little bit of grit. It might not come to you right away. You might need to try it a couple of times, but there is a correct answer. You can do it. It is possible. I'm going to finish this off with one that is a little bit more difficult yet. In this example, you're not just going to have to keep track of 2 atoms, but you'll have to keep track of 3 different atoms on the left side and right side of the reaction arrow. Now this reaction is calcium plus Na2O gives you CaO plus Na. Now if I write out my little cartoon drawings underneath each one, the first thing I'm going to do is put in 1 atom of calcium right here. Next, I'm going to draw out this molecule with sodium on either side and an oxygen in the middle. Next, I'm going to draw just calcium bonded to oxygen. And finally, once again, just an atom, but this time it's an atom of sodium. On the left, I had an atom of calcium. Over here, I have an atom of sodium. Now let's tackle this one atom at a time. Let's first take a look at the calcium on the left. There's only 1 of them, and over on the right-hand side, there's only 1 calcium on the right. So as of right now, those are balanced. Now over here on the left-hand side, let's take a look at the sodium. Now there's 2 sodiums on the left, but only 1 on the right. Well, since there's more on the left than there are on the right, well, I need more on the right. So I'm going to take that sodium and I'm going to make a copy of it. Now I have 2 sodiums on the right and 2 sodiums on the left. Finally, I take a look at the oxygen and see that there's one on the left and one on the right. And now that I've gone through each element individually and made sure that each of them are balanced, now I can finally write in the answer to the balanced chemical reaction. So there's 1 calcium, 1 sodium oxide, 1 calcium oxide, and 2 atoms of sodium. And I put a 2 there because there were 2 individual atoms not bonded to each other. If they were bonded, there'd be a little 2 behind it. But since they're separated, unbonded, then the 2 goes out in front. Well, that is an example of an balancing chemical reactions where you need to keep track of 3 elements. Pay close attention to how many elements are on each side. And if there is an opportunity to draw some cartoons underneath, I strongly recommend that you draw them out so that you can more easily and more visually recognize what you have more of to help you generate the answer. But ultimately, the answer to these problems are putting the correct numbers out in front of the atoms or molecules in front of the actual chemical reaction. Well, that takes care of this video lesson. Thanks for watching.